So yeah, today I'll be talking about computer security incident response teams, or these are also sometimes called computer emergency response teams, or CERTs. They try not only to prevent security breaches, but also to repair the damage after an attack. That's often their focus is on the response rather than the prevention. So what I'm going to talk about today is how these teams have attempted to build a global infrastructure to coordinate their operation. So when we're talking about computer security incident response teams, they really have two different relationships to infrastructure. One is that they are developing infrastructure because they're trying to develop infrastructure to communicate and coordinate with one another. But their ultimate goal is to maintain a different infrastructure, whatever computer systems that they're charged with trying to protect or respond to when there's an incident. But the argument that the paper makes, and that I'll just reiterate today, is that while incident responders tried to develop an infrastructure that was truly global, that transcended geopolitical boundaries, in practice that infrastructure was somewhat fragmented. And I also want to argue that despite what we might assume, this is not because maintenance is intrinsically local. In fact, some kinds of incident response infrastructure did become global. But the infrastructure that the incident responders were really focused on developing was fragmented instead by reliance on local and regional trust networks, which in turn tended to be shaped by regional institutions and needs. So to show what's at stake in incident response infrastructure and why trust really matters, it's helpful to go back to the very first incident that sparked the development of computer emergency response teams as a kind of organizational form. So it was in this context of a rapidly expanding organizational field that two leaders in the field argued that, quote, a global response infrastructure was needed to, quote, replace a less reliable system based on trust between individuals with a reliable and effective system based on global understanding and agreement, end quote. And they cited the response to the Melissa virus, which struck the internet on March 26, 1999, and spread worldwide faster than any previous virus to date at that point, as evidence of the need for improved coordination. But according to the two leaders who wrote this report in 1999, quote, most of the global map was blank. And although the CERT Coordinating Center continued to be treated as an authority and to help coordinate incident response worldwide, its coordination was inadequate to meet the regional needs of many teams. So, for example, time zone differences meant that the coordinating center in Pittsburgh wouldn't respond as quickly when it was late at night in the United States, but still in the workday in Europe or Asia. So there was a need for better coordination in other parts of the world as well. And over the next decade, incident responders worked to develop several types of infrastructure. So the European CSIRT group and the Asia Pacific group both helped to broker relationships between established teams and new teams. In the 1990s, actually exchanging any information about incidents could be very slow and time-consuming. This was partly because there was no standardized way of describing incidents. Multiple teams could report on the same problems without knowing that they were actually talking about the same thing. It was also because of the need for trust between teams sharing information. And so you don't want to just push this out on the World Wide Web when you have information about a vulnerability or an attack. And so the slowness of information exchange was a big problem, right, at a time when attacks moved very quickly around the world. So in 2000, leaders in the European incident response community organized a working group to develop a standard, what they called the Incident Object Data Exchange Format, IODEF, and an associated application that would automatically exchange information about incidents. And initially, this work was supported by Terina. And to gain Terina's support, this is a regional organization, they advanced a somewhat parochial argument. They said that the, quote, successful implementation of the IODEF would contribute to Terina and TFC CERT recognition in Europe and worldwide. They also said this project was, quote, a first Europe initiative in an area where all previous attempts had been US-based. So in order to gain the support of this regional organization, they're kind of pitching it as a uniquely European infrastructure. But more importantly, by 2002, Terina felt like it was consuming too many resources and it wasn't primarily a European initiative anymore, so they withdrew their support. Now, while moving standard development to the Internet Engineering Task Force was good from the perspective of creating something that was truly global and not just about Europe, It also complicated the final standard and made it all too flexible. So what that means is if you have different groups using the same standard in different ways, they actually can't communicate because they're not implementing it in the same ways. So while flexibility might sound good, what it meant was that the organizations sharing data had to agree on how to use it. So despite being a global standard, in practice, many different implementations of this standard entered into use, and each was shaped by the needs of specific partners in incident response coordination. Basically, I've argued that while efforts to develop a global infrastructure for incident response were developed by a transnational community, the reliance of that community on regional institutions, coupled with regionally specific needs, ultimately fragmented that infrastructure and limited the scope of transnational cooperation in cybersecurity.